Bismillahirrahmanirrahim. In this video, we are going to discuss a group frequency distribution. What is exactly a group frequency distribution? It is a table to organize data in which the data are grouped into classes with more than one unit in width. It is used when the data is large. So let's look at to this example here. The age of 50 students in a private university are shown below. Construct a frequency distribution for the data using 5 equal classes. Start with the lowest values, compute the midpoints, relative frequency, and cumulative frequency of each class. So what is the first step to create a group frequency distribution? So the first step here is we need to calculate the range. So of course you have to make sure the data is large enough for you to construct a group frequency distribution. So for this case, we have 50 raw data here. So it is suitable for us to group this data into several classes. So since the instruction here asks to construct using 5 equal classes, then we have to construct using 5 equal classes. So the first step here is we have to calculate the range. So what is the range? Range is the maximum values minus with the minimum values, or the data with the highest values from the observations minus with the lowest values. So in this example, our highest values here is 39 and the lowest values here is 17. Therefore, we will get the range is equivalent to 22. Next, we have to calculate the class width. In order for you to calculate the class width, you have to determine how many number of classes that you want to have. Normally, we'll use 7 to 20 classes. So in this case, the instruction asks you to construct by using 5 equal classes. So we will use 5 classes. So the range that we have just now is 22 divided by the number of classes, which is 5. So we will get equals to 4.4. So class width must be in terms of whole number. So what we have to do with these values, so we have to always round up the class width to the next whole number. Meaning that 4.4 we will get equivalent to 5. So our class width in this example is equals to 5. Okay, next we have to calculate the class midpoints. Okay, before we calculate the class midpoints, let us construct the class limit for all the 5 classes. Okay, for example here, we need to start with the lowest values. So our lowest values just now is equal to 17. So we will put the values of 17 here. So since the class width is equals to 5, so what we have to do here is we will plus with 5 to get the lower class limit for the next class. So 17 plus 5. So you will get equivalent to 22. So it will become the lower class for the next class, for the second class. And then for the next class, we will get the lower limit by using the same method. So 22 plus 5 is equivalent to 27. And then 27 plus 5, so we will get 32. And 32 plus 5, we will get 37. Therefore, all the values that we get here, it is the lower class limit for all the 5 classes that we need to have. And then what we have to do in order to get the upper class limit, so we just have to minus with 1 from the lower class limit for the next class. So for example here, our next class, the lower class limit is 22. So minus 1, you will get 21. So our first class will be 17 until 21. Same goes to the next one. So we have here 27. So minus with 1, so we will get 26. Then this one we will get 27 until 31. The next one 32 until 36. And the last one we can just guess 37 when you plus 5. So you will get equivalent to 42. So 42 you minus 1, so you will get 41. So our last class is from 37 until 41. Next one, how can we get the class boundaries? So since there is no decimal point here, so the class boundaries should be plus minus 0.5. So for the first class here, 17 until 21, our class boundary should be 16.5 until, and then the upper class boundary we have to plus with the 0.5, so we will get 21.5. and then the next one 21.5 until 26.5, 26.5 until 31.5, 31.5 until 36.5, and 36.5 until 41.5. So this is all the class boundary for 5 classes. And then how can we get the class midpoint? So the formula for the class midpoint is equivalent to the lower limit plus with the upper limit divided by 2. So I will show you the first example. For the first class, we have 17, lower limit, upper limit is 21, and then divided by 2. So we will get the class midpoint is equivalent to 19. So we will proceed with the same method. So 19, then this one for the second class, 22 plus 26 divided by 2. So you will get 24. This one you will get 29. The next one 34. The next one is 39. Then the next one we have to calculate the frequency. So meaning that you have to calculate how many students with the age between 17 to 21 from this raw data. So we call this one as a raw data. So 17 until 21. So you have to calculate. Then you will get the frequency for the first class is 15. For the next class is 19. Between 27 to 31 is 9 students. And then 32 until 36, there are 6 students. And the students with the age 37 until 41, we have only 1. So for you to make sure your answer is correct, you have to total up this one. So you have to make sure the total frequency is equivalent to the total number of students, which is 50. Okay, next we proceed with the relative frequency. So what is the relative frequency? It is equivalent to the frequency divided by the total frequency. So I will show you one example here. So for the relative frequency for the first class, so we have 15, and then divided by total frequency is equals to 50. So we will get equivalent to 0.3. So normally we will take 2 decimal point. So we will put here, since it is 0.3, so you can just put it as 0.30. And then the next one, 19 divided by 50. So you will get, with the 2 decimal point, we will get 0.38. Then the next one, 0.18. 0.12, and the last one is 0.02. Then we have to calculate the cumulative frequency. The cumulative frequency is equivalent to, the first one will start with the first frequency of the first class, which is 15, and then plus with the next frequency, which is frequency for the second class, so plus 19, so we will get here 34. Then 34 plus 9, so we will get 43, and then plus 6, we will get 49, and the last one must be equal to the total number of students. So 50, total number of students is also 50. So actually the column that you have to fill in here, it depends on the requirement. So for this case, I just want to show, even though there is no requirement for you to write down the class boundary, but I would just want to show how to calculate the class boundary. So for this case, you can see there is no boundary. So if you just look at to the class limit 17 until 21, so let's say it is not about age, so let's say your data, you have the values is 21.2, so where do we have to put that values? So we have to put, let's say it is 21.2, so it should fall within the first class limit between 17 to 21, because we are referring to this class boundary. So 16.5 until 21.5 will fall in the first class limit. So that is why we need to have these class boundaries, the column for the class boundaries. And then class midpoints, we will use these values to calculate the standard deviation and variation later on. And for the cumulative frequency, we need to have this one for you to draw the OGIF later on. So I think that's all. Thank you.